Formica Laminate is a brand of composite materials manufactured by New Zealand-based Formica Group. The material was invented in 1912, and is manufactured for a variety of applications today. In common use, the word Formica refers to the company's classic product, a heat-resistant, wipe-clean, plastic laminate of paper or fabric with melamine resin. Formica Group, a division of the New Zealand company Fletcher Building, consists of Formica Canada, Incorporated, Formica Corporation, Formica de Mexico S.A. de CV, Formica IKI, Formica Limited, Formica S.A., Formica S.A.S., Formica Taiwan Corporation, Formica Company, Limited, and Formica Limited, among others. Invention. Formica laminate was invented in 1912 by Daniel J. Akner and Herbert A. Faber, while working at Westinghouse. They filed for a patent on it on February 1, 1913. They originally conceived it as a substitute for mica used as electrical insulation, made of wrapped woven fabric coated with Bakelite thermosetting resin, then slit lengthwise, flattened, and cured in a press. They left Westinghouse immediately afterwards. Formica laminate now refers primarily to the decorative product composed of several layers of kraft paper impregnated with melamine thermosetting resin and topped with a decorative layer protected by melamine, then compressed and cured with heat to make a hard, durable surface. Etymology of the name: the mineral mica was commonly used at that time for electrical insulation. Because the new product acted as a substitute o Formica Euro, Faber used the name oe Formica Euro as a trademark. History: Euro unregistered trademark. Connor and Faber quit Westinghouse to start their own business, enlisting lawyer and banker John G. Tomlin as an investor. Tomlin put up $7,500 and became a silent partner in the fledgling business. The company began operations on May 2, 1913, and was immediately successful. By September, Formica Products Company had 18 employees trying to keep up with the demand for electrical parts for Bell Electric Motor, Ideal Electric and Northwest Electric. After the General Bakelite Company chose to sell resin for sheet insulation only to Westinghouse, they switched to a similar competitive phenolic resin, Redmanol. After patent litigation favorable to Barrickland in 1922, the Redmanol Chemical Products Company was merged with the General Bakelite Company and the Composite Company to form the Bakelite Corporation. An important application devised in the 1920s was the use of phenolic laminated fabric for gears. Cut on conventional hobbing machines, the gears were tough and quiet, which was important for automotive timing gears. By 1932, Formica Insulation Company was producing 6,000 gear blanks a day for Chevrolet and other car makers. In 1927, Formica Insulation Company obtained a patent on an opaque barrier sheet that allowed the use of rotogravure printing to make wood-grained or marble surface laminate, the first of many innovations that were to associate the name Formica with decorative interior products. In 1938, melamine thermosetting resin was developed by American Cyanamid Company. It resisted heat, abrasion and moisture better than phenolic or urea resins and could be used to make more colors. Soon after, the Formica Corporation was buying the entire output of melamine from American Cyanamid. During World War II it manufactured wood plastic impregnated wooden aeroplane propellers and bomb parts. Post-war, engineering uses declined, ceasing in 1970 in favor of decorative laminates. The company was headquartered in Cincinnati, Ohio, for many years. After WWII, it entered the European market through a license agreement. Acquisitions: in 1956 American Cyanamid acquired Formica Corporation. The principal reason was to have a captive buyer for melamine, as Cyanamid was one of the largest producers. However, this was soon thwarted due to an antitrust action by the U.S. Department of Justice. Through a settlement agreement, Formica Corporation was required to buy a significant share of its melamine needs from competing producers. Cyanamid operated Formica Corporation as a fully consolidated subsidiary, rather than as an operating division, allowing it to retain the term Formica as a corporate name. This gave added protection to the trademark, helping to protect the word from becoming generic euro, which had been tried by many competitors, against whom Cyanamid gained legal injunctions euro to protect this valuable trademark name. Daniken, son of the inventor, continued as president of Formica Corporation after the acquisition, and was widely regarded as the next chairman of American Cyanamid. However, he was thrown from his horse during a steeplechase event, suffering a broken neck and becoming quadriplegic, ending his business career and, many executives felt, preventing Cyanamid from achieving the growth and profitability it might have. After a 1984 management buyout from American Cyanamid, Formica diversified with products such as solid surfacing, metal laminates and flooring materials. Since 2007 it has been a subsidiary of the Fletcher Building Group, which purchased it from private equity investors Cerberus Capital Management, LP and Oaktree Capital Management, LLC. Product evolution: decorative laminates were made by impregnating large sheets of kraft paper with phenolic resin, which was then partially cured and cut to sheet lengths at the oven exit. The dry-treated sheets were stiff and somewhat brittle. A decorative sheet, impregnated with melamine resin and B-staged and cut to length in a similar manner to the phenolic core sheets, was laid on a polished stainless steel press plate. Then several plies or layers of kraft paper impregnated with a phenolic resin were placed on top of the decorative layer. The number of plies of kraft used yielded products of varying thickness depending upon end-use requirements. Next, a sheet of release paper that would not bond to the phenolic resin was placed on top of the phenolic kraft, and following this a mirror image build-up of the assembly already on the press plate. Finally, another polished stainless steel press plate was placed on top of the pack assembly. On the other side of this plate another similar assembly was built until there were several laminates in one press pack to go into a single opening in the hydraulic press. The huge hydraulic presses, perhaps 5 feet by 12 feet, had many heated openings, thus many laminates could be produced in a single press cycle of about 1 hour duration. Great pressure were applied to each press pack. The B-staged melamine and phenolic resins first flow to bond the interlaminar plies together. Then the plastic resins thermoset to provide a very durable product that could tolerate much heat and abrasion. A variant was to use a slightly roughened steel sheet atop the cover sheet, producing a laminate with a matte surface. A similar effect can be achieved using various types of release paper between the steel press plate and the decorative melamine surface. Some users considered this more attractive than the gleaming, absolutely flat surface created by the highly polished stainless steel separators. After being removed from the press, the individual laminates were sanded on the phenolic kraft side to a uniform thickness. This sanding operation also increased the back surface area so the more secure bonding to a substrate such as a kitchen counter could be achieved. This lamination process was costly and labor-intensive. It required extensive handling of the individual sheets. Those sheets were more brittle than potato chips, hence easily damaged. Breaking off even a small corner rendered the sheet unusable. Yet no better process had been devised, since the inception of the product. After a meeting of the parent corporation's Research Coordinating Committee, Cyanamid's Director of Corporate Development and Planning, Mr. Kent L. Aldershoff, suggested a new approach to Formica's Research Director, Dr. Arthur Giddings. The proposal was to bypass the entire process of making paper and impregnating individual sheets, to be subsequently laminated. Instead, Aldershoff proposed making a thick paste of cellulose powder and phenolic resin, to form the core in a single piece prior to curing. The melamine impregnated cover sheets would be laid atop that, informing the press packs. This approach was pursued in the Formica Research Laboratory, with some success. Thereafter, Formica decorative surfacing was produced with what was termed Corex core. The product was never commercialized for 2 reasons. First, the expected economics were not there. It was found that the only suitable source of cellulose fiber came from sheets of kraft paper that had already been made and were then ground up, and the resultant laminate had different physical properties. Secondly, laminates traditionally made from plies of paper have different length and cross-physical properties, and the industry grew and developed based on rectangular laminates, so cross-plying was not possible. The Corex core provided uniform cross and length properties which, while seeming to be an advantage, was not, because of the way the entire industry of laminate application had developed to account for the non-symmetrical property. A further advantage may have been that the core material could be impregnated with a pigment, approximately matching the color of the top sheet that would later be applied. The phenolic resin turned very dark brown during curing, so that a narrow brown line would show when the material was later used in a countertop. Pigmented unified core wood provided an edge largely indistinguishable from the surface color, giving a more pleasing overall appearance to the product. Since the Corex product could not be commercialized for the reasons described above, a more conventional method was developed to make the product called color core that provided uniform color throughout the laminate and eliminated the brown line. An interesting variant of the product was also developed, known as deep textured Formica surfacing. Use of the cellulosic paste allowed using a deeply textured, or even sculptured, metal press sheet atop the decorative sheet, producing a formed surface. The researchers overlaid the stainless steel sheets with furnace cement, a material easily sculptured or textured, and able to withstand the high heat during curing. They would carve into the cement an illustration, such as natural slate in negative form. When the furnace cement hardened, and the sheet was used in a press pack, the final unified core product would have a raised or three-dimensional image. It was thought that such an approach would lead to producing large panels, usable for example as wall decor in a hotel lobby or corporate office. In a further development, the researchers used very thin copper sheets in place of the decorative sheet. The overall effect was like a large metal medallion, or a copper sculpture. Many impressive samples emerged from the research lab. The product simulating natural slate proved to be a very popular product and was a leading seller for many years. A decorative edge known as Ideal Edge was originally invented by John W. Pugh and then bought by Formica Corporation. All rights to the product now belong to the Diller Corporation, or Formica. Relatives, Arborite, a similar and also popular paper melamine composite, was developed in Canada in the 1940s. Makata, trade name for Westinghouse decorative laminates, now produced by Norplex Makata, a line of laminates similar to Formica is made by Wilson Art International, Temple, Texas. Laminates similar to Formica, but with top surface made of multilaminar veneer and sprayed with resin are called Alpicard, is made by Alpispar. Consaworld similar 20th century product manufactured by Consolidated Paper of Wisconsin. See also, melamine. References. External links, official website.